What is plasma? Welcome to another episode of Fact Channel, where we explore the wonders of science and technology in a concise and clear way. Today we'll be talking about plasma, the fourth state of matter that many people may not know much about. But before we dive in, let me ask you this: what are the other three states of matter? If you said solid, liquid, and gas, you're correct. These are the forms that most substances can take depending on their temperature and pressure. Solids have fixed shape and volume. Liquids have variable shape and fixed volume, and gases have variable shape and volume. But there's another type of matter that exists at extremely high temperatures or low pressures, and that's plasma. Plasma is a state of matter that consists of charged particles, ions, and electrons that are not bound together in atoms or molecules. Instead, they move freely and interact with electric and magnetic fields. Plasma can be created by heating a gas, exposing it to a strong electric field, or subjecting it to a high-energy source such as a laser or a particle beam. Some examples of plasma phenomena in nature or technology include lightning, aurora stars, neon signs, and plasma TVs. So what makes plasma different from gas or liquid or solid? Plasma is different from all other states of matter because it's not neutral. It has a net charge, which means it can generate electric and magnetic fields, respond to them, and produce other forms of energy such as light or heat. Why is plasma important for research or applications? Plasma has many applications in fields such as space science, fusion energy, materials science, biomedical engineering, and environmental remediation. Plasma can be used to create new materials or modify the surfaces of existing ones, to sterilize medical instruments or treat cancers, to test how materials or devices behave in extreme conditions, or to clean up polluted air or water. One of the most promising applications of plasma is in the field of fusion energy, which aims to mimic the nuclear reactions that power the sun and stars. By heating and confining a plasma of hydrogen isotopes, like deuterium and tritium, at extremely high temperatures and pressures, scientists can force the nuclei to fuse together and release energy in the form of heat and particles. This process is called nuclear fusion, and it's what keeps the sun shining and the stars burning. However, making fusion energy a reality on Earth is not easy. One of the biggest challenges is to create and sustain a hot, dense, and stable plasma for a long enough time to extract useful energy. The most advanced and widely studied approach is called magnetic confinement fusion, which uses strong magnetic fields to trap the plasma in a toroidal vessel called a tokamak. Dozens of countries are participating in this global effort, hoping to achieve practical fusion power within the next few decades. What are some of the technical hurdles that fusion energy faces? Some of the technical hurdles include developing materials that can withstand the extreme environments of fusion reactors, finding ways to extract more energy from the fusion reactions than the energy needed to sustain the plasma, and reducing the production of radioactive waste and other byproducts. But I'm optimistic that we can overcome these challenges and make fusion energy a clean and abundant source of power for the future. So there you have it, folks. Plasma may be a rare state of matter on Earth, but it's ubiquitous in the universe and has a wide range of applications and implications for our civilization. Plasma TVs to fusion reactors. From plasma cutting to plasma medicine, from auroras to sunspots, plasma is a fascinating and dynamic topic that can teach us a lot about the nature of matter, energy, and the cosmos. As always, hit the subscribe button and like the video. Thanks for watching, and stay curious.